This is James with Fun Media. I'm here at the beautiful Arkansas Regional with 4499 all the way from Colorado. We're going to be going over their premiere night favorite robot today on Behind the Bumpers. All right, starting us off, George, you were going to go over some of the stuff lower down on the robot?
Yeah, so to start off with the chassis, we wanted to maintain a low CG because of how high we had to reach. We wanted to make sure we didn't tip even if we were fully extended. So one thing we decided to do is to actually have a steel beam right here. It helps counterbalance our elevator along with the placement of our battery opposite to the elevator. We also dropped our frame 1 inch to further lower our CG and have our elevator be able to extend an extra inch, and a full unlightened 1/8 inch aluminum belly pan. Moving on to our elevator. Over here, it's a two-stage elevator with our pivot as our carriage. It's driven by two Krakens with Dyneema as our rope. We faced a lot of issues in the beginning with stability and the wiggliness, so we decided that we'd add these tie rods to further support it higher up, so then we could have more accurate placements.
So while we're talking about the elevator and we have it going, so with a two-stage elevator, was that part of the reason why you guys went with such a long end effector, so that way you could keep the elevator 2 stages and not go all the way to 3?
So the long end effector allows us to both pick off the ground on both sides of the robot, as well as easily score the algae using our algae end effector into the net. So that's one nice thing about having our end effector so long.
All right, and Gene, you wanted to go a little more in depth on that?
So for our end effector, it's pretty hard. We wanted to start off with ground intaking, and we initially wanted to do a pass off where you have two intakes on each side that pass off to a vertical arm, but we thought that was a little redundant and complex, so we chose to have a ground intake that's all attached to a twist and a pivot. For our twist, we chose to go with a X44 to reduce weight, and for our end effector, we wanted to create something that was light, did both game pieces, and was easy to touch and take. And we found that with this version, it's not the best at touch and take and intaking from all orientations, but it's easy enough to be as effective as a touch and take while with enough driver practice. So we have these 2 prongs out here that provide stability for our algae, and then we just have this little area right here, all driven by 1 wheel in order to intake our coral.
All right, so you said that you wanted to keep it as light as possible. So what type of materials did you actually use, and what kind of decisions did you make to get that lightness really well done?
So we chose to use an X60 up here because we needed the torque, but for this we used all polycarb and carbon fiber in order to reduce as much weight as possible.
All right, and George, you wanted to talk to us a little bit about the climber to wrap up some of the technical stuff?
So in the end game, what we wanted to do is to be able to grab the cage and climb within about 10 seconds. So in the last 20 seconds, we deploy our climber. We have 2 stationary hooks right here that latch in and can't be backed out. We just have a winch on a worm gear, 90-to-1. And now we grab the cage with these 2 spring hooks. And then once we do that, we just pull back and then we're off the ground.
All right. And so before we move on to some of the programming stuff, is there anything mechanically you guys are looking to improve between this event and your next?
Yeah. For our intake, these carbon forks, they do work well, but we want to experiment with double-sided rollers in order to get more of a grip. Along with this, we've had some problems with our CG and our climber working well together, so we still need to balance that out. But
all right. And then Rashab, you were going to go over some of the programming aspects?
Yeah, so on this robot, we are fully localizing. Right here, we have a camera stick that has 4 cameras on it that are running on 2 orange pies running photon vision. This allows us to fully localize at any point on the field, and this allows us to auto place. With auto placing, we can place on any branch of the reef automatically. We choose the closest branch to the reef when the driver presses the button, make it super fluid and easy and precise. When in this the reef state, where we localize off of 1 tag that's on the reef to help increase our precision. Our localization also utilizes a common filter and tons of other filtering to help increase its accuracy and reduce some of the noise. Core-take regression changes the weights of our vision estimates, and that helps increase our It increases the weights once we're closer to tags, which makes it a lot more reliable and a lot more accurate.
All right, and so with all that vision processing and things like that, if there's one place you could add an April tag to make your life easier in this game, where would you put it?
I'd say I would add it on the alliance wall, because then we can see multiple tags while we're going to place on other sides. And because on the other sides we can already see processor, feeder, barge tags, whereas on the close side to the driver station we can't actually see a second tag before we go to place. So that will help increase the accuracy there.
All right. Thank you so much, Rashab, Gene, and George for talking to us today. You guys are always a favorite over on Fun, and we're looking forward to see how you guys do this season. Thank you all today for tuning in on Behind the Bumpers.